Model evaluation in ML workflow. Model evaluation in ML workflow. AI beginner level. Introduction. After training a machine learning model, the next important step is model evaluation. Model evaluation helps determine how well a trained model performs on unseen data. Even if a model performs well during training, it may not perform well in real-world situations. Therefore, evaluating the model is essential before deploying it. Model evaluation helps developers measure model accuracy, compare different algorithms, detect overfitting or underfitting, improve model performance. Model evaluation is used in many AI systems such as fraud detection, medical diagnosis, spam filtering, recommendation systems, customer behavior prediction. Understanding model evaluation helps beginners learn how to measure machine learning model performance. What is model evaluation? Model evaluation is the process of measuring how well a machine learning model performs using test data and evaluation metrics. In simple words, model evaluation equals checking how accurate and reliable a trained model is. Example concept. Trained model means test data means performance metrics. Model evaluation ensures the model can generalize to new unseen data. Why model evaluation is important. A trained model may perform very well on training data but poorly on new data. This happens because the model may memorize the training data instead of learning patterns. Example concept. Training accuracy does not equal real-world performance. Model evaluation helps detect problems such as overfitting, underfitting, biased predictions. It ensures the model is reliable and useful. Training data versus test data. To evaluate a model properly, the dataset is split into different parts. Typical dataset split. Training data, used to train the model. Validation data, used to tune the model. Test data, used to evaluate final performance. Example concept. Dataset means training set plus validation set plus test set. The model is evaluated using test data that it has never seen before. Evaluation metrics. Evaluation metrics measure how well the model performs. Different metrics are used depending on the problem type. For classification problems, common metrics include accuracy, precision, recall, F1 score, confusion matrix, ROC curve and AUC. Example concept. Predictions means compare with actual labels means performance metrics. Accuracy. Accuracy measures how many predictions are correct. Accuracy formula. Accuracy equals correct predictions, total predictions. Example. Prediction actual. Spam spam. Not spam not spam. Example concept. Correct predictions means higher accuracy. Accuracy is easy to understand but may not work well with imbalanced datasets. Precision. Precision measures how many predicted positives are actually correct. Precision formula. Precision equals true positives. True positives plus false positives. Example concept. Predicted positives means how many are correct. High precision means fewer false alarms. Recall. Recall measures how many actual positives were correctly detected. Recall formula. Recall equals true positives. True positives plus false negatives. Example concept. Actual positives means correctly detected positives. High recall means the model detects most positive cases. F1 score. The F1 score combines precision and recall into one metric. F1 score formula. F1 equals 2 times precision times recall, / precision plus recall. Example concept. Precision plus recall means combined score. The F1 score is useful when both precision and recall are important. Confusion matrix. A confusion matrix is a table used to evaluate classification results. Example. Predicted positive, predicted negative. Actual positive true positive false negative. Actual negative false positive true negative. Example concept. Prediction results means confusion matrix. It helps analyze different types of prediction errors. ROC curve and AUC. The ROC curve shows how well a classification model distinguishes between classes. It plots true positive rate, TPR, false positive rate, FPR. Example concept. Different thresholds means ROC curve. The AUC score, area under curve, summarizes the model's performance. Higher AUC means better classification ability. Regression evaluation metrics. For regression problems, different metrics are used. Common regression metrics include mean absolute error, MA, mean squared error, MSE, root mean squared error, RMSE, R-squared score. Example concept. Predicted values minus actual values means error measurement. Lower error means better predictions. Cross-validation. Sometimes a single train test split is not enough. Cross-validation evaluates a model using multiple dataset splits. Example concept. Dataset means multiple training, testing cycles. This provides a more reliable estimate of model performance. A common method is k-fold cross-validation. Comparing models. Model evaluation helps compare different algorithms. Example concept. Model A versus Model B means compare evaluation metrics. Developers choose the model with the best performance metrics. Example Python code. Model evaluation is often done using Python libraries. Example using scikit-learn. From sklearn. Metrics import accuracy _ score. Example evaluation. Accuracy _ score. Y _ test. Y _ pred. These tools help calculate evaluation metrics easily. Real-world applications. Model evaluation is used in many AI systems. Healthcare. Evaluating disease detection models. Finance. Measuring fraud detection accuracy. E-commerce. Evaluating recommendation system performance. Cybersecurity. Testing intrusion detection systems. Marketing. Evaluating customer prediction models. Concepts learned from model evaluation. Understanding model evaluation helps beginners learn. Checkmark how to measure machine learning performance. Checkmark how evaluation metrics work. Checkmark how to detect overfitting and underfitting. Checkmark how to compare different machine learning models. Checkmark how to improve model reliability. Model evaluation is essential before deploying machine learning models. Simple definition. Model evaluation. The process of measuring how well a trained machine learning model performs using test data and performance metrics. Final summary. Model evaluation is a critical step in the ML workflow. After training a model, developers evaluate it using test data and performance metrics such as accuracy, precision, recall, F1 score, and error measurements. Evaluation ensures that the model performs well on unseen data and is reliable for real-world applications. Understanding model evaluation helps developers build more accurate and trustworthy machine learning systems.